So since we got caught up on this other part, I'm going to go through the last part kind of quickly. So what we find is the number of ways to write, so we'll let R of n equal the number of ways to write n as the sum of squares. It wiggles around a bit. R of 0 was
1.
R of 1.
4.
R of 2.
It's also 4.
4. R of 3.
0.
0. R of 3 mod 4.
0.
0. But other numbers can get big, and the book says actually you can make this number very big, as big as you want actually. If you pick any number that you pick, you can find a number, like if you picked 100, we can find numbers where R of n is bigger than 100.
So it can get infinitely big.
Yeah, it can get infinitely big. So it's hard to understand kind of what this function is, but an interesting question becomes to take the average of it. So we could do the average equals R of 0 plus R of 1 plus R of n. So I mark there. Divided by n, and look at that as n gets really large. Okay, so that's the problem Gauss looked at. So hard to say anything about the function itself, but maybe we can say something about the average. And that tells us if we pick a number, pick an integer at random, positive integer, I guess, how many ways are there to write it as the sum of squares? Alright, so here was Gauss's idea. And this was actually pretty amazing.
Alright.
Are you sitting down?
No.
Oh, too bad. So Gauss said, I'm going to look at the plane, and I'm going to look at the integer points on the plane, which are sometimes called lattice points. Okay.
Yes.
Each of these lattice points represents two integers. So here's the point 2, 1, for example.
Yeah.
What's this point here?
-2, -2.
Yeah.
So if there's a way to write some integer as the sum of squares, it'll show up as being as a lattice point. Every one of these lattice points, when you square them in sum, for example, this one is 5, this one's 8. It shows up here as a lattice point, right?
Yeah.
Yeah.
Every time, every pair, because we're looking at, we basically get every pair of integers.
Yeah.
Okay. And then he made the amazing observation that if I look at circles here of radius k, so I'm going to do radius root k. Well, this is the circle, say, x squared plus y squared equals k. Right? That's the equation of a circle, right? X squared plus y squared equals k, and here's my radius, square root of k. Well, inside of this circle, I have x squared plus y squared equals 0, x squared plus y squared equals 1, x squared plus y squared equals 2. Well, there's none where it equals 3.
Yeah.
Right?
Yeah.
There's none where it equals 3. Yeah?
Yeah.
Yeah.
But I have all the ones x squared plus y squared up to k, where x squared plus y squared equals k. Okay, in other words, I have r of 0, plus r of 1, plus r of 2, all the way up to r of k. And my circle of radius k.
Square root of k.
Square root of k. Alright? So this sum up to k is approximately what? Can you see what it is when I add up all the number of lattice points inside of a circle? What is that approximately equal to?
The area of the circle?
Yeah. Why is that?
Because, like,
I mean, you could
it's sort of like count.
almost
the unit.
approximate that the circle is a box.
Okay. each one of these lattice points
Yeah,
has
they
a
have a
box
box.
around it of radius 1.
So you could sort of just count the boxes.
Yeah, you can count the boxes. Now, there's going to be some problems where you have a box that's partially in and partially on it.
Yeah.
And I'm going to skip over those details today. It's actually not that hard. And maybe we'll do it another time. But this is approximately equal to the area of the circle, just pi times k. But we were trying to find the average of this, which is just R0 plus R1 plus R2 all the way up to RK divided by k.
It's just going to be around pi.
Yeah. So how about that for a weird result?
Strange.
The average number of ways to write an integer as a sum of 2 squares
Around pi.
is pi. In fact, it gets exactly pi as you let this go to infinity. This approximation becomes better and better and better.
That's really
Very
weird.
strange.
Yes, that is really weird. Amazing. Amazing though, right?
Yeah.
Mm-hmm.
It's an amazing connection between arithmetic and geometry. And we got distracted by a fun part of this of just how to write a specific square. But this is a great book, and it has lots of fun projects in it.
Yeah.
Anyway, you guys like it?
Yeah.
All right. Good work this morning.